Tom Phillips back again, and so we thought we would end up here with some program on fumigation, mainly because this is the
Oh, there's one.
okay. Anyway, I refer to fumigation as the hammer. You know, it's what people use in grain bins, and and when they want to solve the problem. And again, you know, back to why are we storing grain? It's to make money. I mean, the quality of grain is the highest at the time of harvest. And we want to try to hold it close to that during storage. And the reason you store grain, my economist friends tell me, is you're trying to get a better price later, okay? And we all know that the prices right after harvest are probably the lowest per bushel, and then they go up. So fumigation works into that a lot, and it is not entirely okay. So I'm going to talk about what is a fumigant in this slide first, and it is a toxic chemical pesticide applied in the gas phase. Basically, that's what separates it from the others. It has no residual activity. I'll get to that later. Here's that comment about the hammer. Okay, it is intended to disinfest when it's needed. So again, for IPM, we want to ask the question: do I need to use that hammer or not? And in many cases, you're not. You know, so this is the idea of don't use it unless you need it. And so it's nice to have some monitoring information to know if you need it or not. Since it acts as a gas, it leaves very little to no residue. So you see, I can't really say no residue, zero residue, because if we look hard enough and long enough, we can find little bits about it, but nothing that's going to kill you or insects. So it goes in and it kills in a matter of hours, minutes, hours to days, depending on the concentration as such. The uses, of course, for fumigation and stored products are for the commodities, the raw commodities that we're talking about, the grains. It can be in a building, such as a warehouse, a mill, and so forth. For example, almost every flour mill in North America was fumigated with methyl bromide at least once a year a while back. Now, because of the ban on methyl bromide, it's not being used at all. Other things are. In transit, okay, grain is fumigated in transit on trains, on rail cars. That is legal, still on the label, and also in ship holds and on barges, not on trucks. I realize I didn't mention that later, but we hope that everybody's reading the label, and I shouldn't have to repeat that. The other thing that ought to be, I want everybody to understand, is it is a really dangerous insecticide for anybody getting close to it. So the applicators, the person putting it into the grain, and of course the bystanders have to be protected. And that's where the EPA is coming out on this buffer zone issue. You know, they're looking at a toxic compound that acts as a gas. They don't want people to have their office inside the grain elevator. I'm being facetious, but that's kind of where that buffer zone stuff comes from. And this is the part that I can't stress enough. It is very dangerous stuff. That's why the label and also the container itself has the internationally recognized skull and crossbones. So even if people don't speak English and they haven't heard a great webinar like this one, hopefully if they see the skull and crossbones, they know that it's bad stuff. There are variables that we know now will affect the success of a fumigation. First of all, the species, and that's why the species of the pest, so that's why we talk about identification and so forth. It could be that some insects, and we know this in the case of, say, the lesser grain borer, may be more tolerant, they're not killed as fast, and so forth. So the target species is important, although we do want to kill every species that's there, okay, every grain insect species that's in your sample. The one that's going to affect the effectiveness a lot more within those species is the life stage. And it turns out that the egg and the pupa are the most difficult to kill. And this really has to do with how much they're breathing compared to breathing air compared to the larva and the adult. The larva is the feeding stage, and it's busy, you know, eating grain and breathing and doing all sorts of stuff, as is the adult. The egg and the pupa are not breathing very much. They are breathing, but this is the ones we need to get at with the fumigant. the concentration of the gas, okay? These last three are really the most important. After you know how much you need to kill the egg of the most tolerant species, then you got to be able to control yourself, the concentration of the gas, the time that you have the commodity under gas, the exposure time, and the temperature of your grain. Okay, so that's when we had the question about cold grain and all that, I actually might have been mixed up in what I was saying initially, but there are a couple reasons you don't want to fumigate cold grain, and one of them is it just won't work at cold temperatures. The other one is that you're not going to have the reaction of the phosphine product very well at the cold temperatures. So you want warmer grain, you want a long exposure time, and you want the most effective gas concentration, and I'll just say among the highest that is allowed by the label. That's going to give you a good fumigation. What I'm not mentioning on here is that you can hold that gas concentration when your facility, your bin, or your silo is well sealed. So, this is a quick one because we only have a few to work with. This is registered methyl bromide, but it's banned, and we wouldn't be using it on grain anyway. It's been banned under the Montreal Protocol and the Clean Air Act. Phosphine is what we're talking about today mostly, but a little bit on sulfuryl fluoride, which is the product called Profume, and that is registered for grain, and it is an alternative for lots of reasons to use on grain. But by far, in the grain business in the United States, we have phosphine as the main fumigant, whether it be in elevators, terminal elevators, or transport in ships. Be a little more technical now. The products that most people deal with are these phosphide salts, and it's almost all in grain going to be the aluminum phosphide, either as the small pills, as some people call them, or the larger tablets. And generating the gas on the very right-hand side of this chemical equation, pH3 is the phosphine gas that we want. But what you're applying in the pellets and tablets is ALP, aluminum phosphide. That reacts with water in the air, water vapor, so moisture. You also don't want a real dry environment, so super dry grain on a dry day will not react as well. But you want that reaction with the moisture in the air with aluminum phosphide to yield the stuff on the right-hand side of the arrow. There's aluminum hydroxide we're not too concerned about, but the one we care about is pH3. That's the phosphine gas. So these pills are not the toxin directly, okay? They are generating the gas, and they require those special conditions to generate it. The other product that's available a lot is magnesium phosphide. It will not be used so much in typical raw commodities, but it will be used when, for some reason, you might want a very quick application of phosphine gas. And the reason that it's quicker and it presents more is that in pretty much the same time period, on the far right of this equation, we have 2 molecules of pH3 being generated as opposed to 1 in the top formula. And that's just for the chemists in the bunch who want to love it. We say that phosphine is cheap, easy, and effective. And I'm pretty sure that statement is true right now today. Among a lot of the other products that have been mentioned, phosphine is pretty cheap per bushel to apply. It's relatively easy if you're certified as an applicator and you're doing it safely, and it can be effective if you do everything the way we're going to tell you how to do it. The gas is very lightweight, so that means it penetrates well through the commodity. The tablets and pellets are very economical when you do the pricing per bushel, especially if you're doing your own application, or even when you hire an applicator, it is more economical or fairly economical compared to losing all your grain to insects. And it is effective for most pests. I'll say pretty much all the ones we're concerned with. Smaller, it turns out mites are difficult to kill sometimes with phosphine, and some of the insects can be resistant. One of the downsides, and I deal with this in building fumigation, is it is corrosive to electrical fixtures, anything made out of copper. And so I took this photo in a fumigation we did inside a building. The elbows, the copper elbows on the top, were kept in a clean room during the same time we had the elbows on the bottom in a fumigated room. Well, this will result in any electrical circuits being damaged. It's particularly bad when you have telephones, computers, and HVAC systems. That's when it starts to get dangerous. So don't use phosphine in the office. don't use, this is why the flour millers will not generally use phosphine in mills and in other situations. That's where you need to be very careful on using other fumigants. And I hope it's showing on here, but some of the insects are resistant, and that is spreading. So we're going to talk a little bit about the phosphine resistance problem. Again, it is the fumigant of choice for these settings. And we have alternatives to the pills and the pellets, and that is cylinderized phosphine. So EcoFume is a product that's out there that is a mixture in a tank cylinder of 2% phosphine with 98% carbon dioxide. And another product is Vapor Phos, which is almost pure phosphine, and it is rapidly diluted with air coming out of this fancy machine here shown in the middle of the slide. Both of these have to be applied by very skilled and experienced applicators, but if you can do it and if it's needed and you can afford it, it's very good for these reasons. It does not require that you go inside a confined space. You apply the material from the outside with tubing and so forth that's going into the grain bin where you want to apply it. It will reach the target concentration pretty darn fast, okay? I've been involved in experimental fumigations where you can get up to target concentration in a matter of hours, whereas the pills and the pellets are going to take half a day, a whole day, what have you, to reach the level that you want. In this case also, if you're measuring the gas concentrations and you notice that they're going down in the grain bin, you can add more gas from a cylinder. But it is more expensive than the solid phosphide. So just so you know that it's out there, and certainly your fumigators know that those are out there, and several of the fumigators have access to these techniques. The problem we have in a lot of the grain storage worldwide is that our grain storage structures, concrete silos and other things, are very old, and we don't need to replace them every 10 or 20 years. A lot of them, unfortunately, are 60 years old, and they weren't constructed with the thought of fumigation. One of the main things is, if you look on the photo on the right, those little black squares are actually wide open into the grain, okay? A lot of the concrete elevators do not have aeration in place, so you really can't cool the grain when it's warm. They are really difficult to clean. As a matter of fact, I can safely say that probably a majority of elevators are not sending workers into the bottom, A, because I think it's illegal under OSHA, but even if you could open it up, there's very few of them that are cleaning out all the bottom crud of old grain and insects. And they're also leaky, and a lot of them for these vents that are in the top here. Now, those vents were constructed for a good reason, and that is to equalize air pressure as you're loading a bin. But there should be alternative ways to do that. If not, though, it requires that before fumigating that you get up there and you seal those vents. And there are ways to do that. Very carefully, of course. But if you don't seal it, remember, phosphine is pretty much as light as air. It does move around based on temperature, so you will lose the gas more readily with those big holes in the wall than you will if they're sealed up. So hopefully we look towards improved structures. And here's an example of one. And if you know who you are, you're watching the webinar, you know that we think highly of your bins. These are really, really large bins, about 250,000 bushels each, I think, or maybe it was 125, but it's a lot of grain. And what's going on here is they have aeration. Don't know if I have arrows on here. They're very well sealed, okay? So they don't have any eave vents. If we look about where the slanted roof meets the vertical wall, there's no gap there, okay? Or there's very little gap, and I know that they go in and fill those gaps. A lot of bins have eave vents, eave gaps, and you don't want that in general if you're going to treat with phosphine. There also is good access for cleaning in this bin. They have a door. When it's empty, they can open up and go inside and clean. They have nice ladders inside. They can get in, open the lids, and that's okay to clean when there's no grain in there. This set of bins, and maybe other people, can have computer-controlled temperature monitoring. So I know that there are temperature cables going up and down, several of them in each of these bins. There's in fact 4 bins here. You can't see the 2 in the back. But also there are aeration fans, and you can see the fans here in the front. There's 2 that are showing on each of the 2 bins. There's also some more around the other sides. These are huge fans that are bringing in outside air to cool these bins, and they can have controllers on them that are reading the temperature of the air and the temperature of the grain. And what we like to say is you want to turn on the fans when the when the grain temperature is 5 degrees or greater, basically if it's greater than the outside temperature. So if your air temperature outside is cooling at night and your grain temperature is still warm, you can bring in cool air. This particular set of bins, if you notice the white pipes going up the side and into the roof, this is a recirculation system. So that piping is picking up, during a fumigation, will pick up phosphine gas in the headspace, and it's connected to a little fan that will suck it down to the bottom and then recirculate it, circulate that gas back into the bottom of the bin, and it'll move it around. Now, the engineers tell me you don't want to keep that recirculation fan going for day after day after day. You do it for a few hours, you get the gas circulated, and then you turn it off. And then you can do it a few more hours, get it circulated. It's very good for moving the gas away from those pellets and into the grain mass. Okay, I was asked to speak about insecticide resistance a bit, and we're doing research on it at K-State. I have colleagues at Oklahoma State, and there are others around the country doing it because we've determined it is a problem. So the textbook definition for resistance is when an insect acquires a genetically controlled trait, the ability that allows it to survive an exposure to a toxin that normally would kill others that lack that trait because they don't have the genes for expressing that trait. Resistance, therefore, since it's genetic, is heritable. In other words, the babies can inherit it from the parents in the case of the insect. They can spread it along every time they survive a fumigation and they mate and have babies. It can also be selected quickly, okay? So this is unnatural selection, but we're doing it with phosphine. Every time we treat grain with phosphine and there's resistant insects in there, we're allowing them to be the parents for the next set of babies. So each fumigation you can select resistant insects, and once those genes are present in the population, this can happen kind of quickly every time that there's a phosphine fumigation. Now, if there's, insects in the grain that are resistant or interbreeding with non-resistant insects, you can dilute that effect for a while. But when everything comes together right, it can be bad. We also use a little cartoon to explain this further. You can have a bunch of healthy insects on the leaf. These are probably aphids or something. And that one insect pictured in red happens to have the mutation that it got by chance, and mutations are happening all the time. But this one is for the gene for phosphine resistance or insecticide resistance. On the right, we show where most of the insects were killed from the spray, but that one red guy is still surviving, a few of his brothers and sisters without the gene. But every time it's sprayed, then the red guys build up until you have mostly red guys. Those are the resistant ones. And so they can go on and carry those genes into future generations. Well, do we have it in grain insects? The short answer is yes, and my colleagues Larry Zettler and Garrett Kupris proved this 25 years ago when they went out and they sampled populations of the red flower beetle, and they found out that 1 out of 8 of the populations they sampled in Oklahoma were resistant to phosphine. And in the case of the lesser grain borer, they found that all strains were resistant, 8 out of 21. All of them were resistant to malathion, dichlorvos, and reldan. Sorry to use a trade name. But 8 out of 21 at that point in the 1980s, late 80s, before they wrote this paper, were resistant to phosphine. Well, the way you test for this is with controlled laboratory fumigations. I'm just showing a little bit about what we do at K-State. We put beetles in little ventilated vials like the ones on the left. We put them in jars like the lower left jars, and then we bring in gas, such as in our basketball here, and we inject it into those jars, and we hold it for a series of time, and we just find out how many die and how many don't. The amount of gas we're putting in there is what we call a diagnostic dose, and it's actually pretty darn low. It is derived from from the dose that would kill really susceptible insects. So the question of do we still have fumigation after Zettler and Kupras did that study 25 years ago? Yeah, and it was because George Opit, pictured on the right here with me on the left, went back out in Oklahoma and studied the same places that Garrett Kupras and Larry Zettler went to. And instead of just one out of 7 populations of Tribolium, red flower beetle, every single one of them had resistance, and every single one of the lesser grain borers had some level of resistance. And not to dwell on the slide too long, what they found in Logan County, for example, the dose to kill lesser grain borers was pretty high. Garfield County, look at that. This is an estimated dose. We had to use some fancy statistics of what would be needed to kill 99% of these lesser grain borers, the LGBs, and it was 1,500 times what would kill a laboratory susceptible strain. I mean, this still has our jaw dropping in some cases, and pretty much it means, from a practical standpoint, those folks in that county, which I won't say any more about it, might have difficulty in that bin trying to control them with phosphine. So there's the 2.6 for the lab susceptibles, and the 3,400 for the field insects, lesser grain borer, and that's just would take 1,500-fold as much phosphine and holding time. And, you know, there's just not a way you could treat them for 25 days at a high concentration and get a good kill. Probably these have resistance. I mean, we're sure they have resistance. We've already studied them that far, and you need to do something about it. We did some assays. You know, us folks in the university can't help but show data to people. This is the red flower beetle using 2 different discriminating doses, one for run-of-the-mill regular old resistance. These are some locations within 100 miles of Manhattan, Kansas. Every single one of these grain bins in different locations are showing the clear bar. They had some level of those open bars had resistance. When we did the next higher dose for discriminating what we call strong resistance, we found it in that one MIN population had a high level of strong resistance, okay? So we've been studying what's called strong resistance, weak resistance, and the feeling is that the weak resistant populations, like WA on the far right, could probably be controlled with a much better fumigation, much higher dose, longer hold time with phosphine. It's these guys with the dark bars like MIN and MIT, but certainly MIN, you have to think about it. So what do? You want to manage phosphine resistance. First thing we say when we're teaching a class on this is stop using phosphine. Well, a lot of people don't want to accept that because they need to sell their grain and they want the insects out. But if you had nothing else to worry about it, one thing is you stop using phosphine, and hopefully those insects that have the genes will go down in numbers and they'll mate with others that don't have the genes. But at some point that's really not going to work, because if a bunch of the insects everywhere in the area have those genes, you're not going to kill them all off. If you have this weak resistance that we're talking about, then treating with phosphine at really high concentrations, you know, within the label for long times could work. And that's what we're doing research on. That's what a lot of people in the field have said have worked. We've got colleagues in Australia who've been dealing with the resistance problem a little longer than us, and they know that they can control weak resistance with phosphine. But again, what the textbook would say in pesticide resistance would say, if you've got resistance to one chemical, switch to another chemical that has a different way of killing insects. And so one of the alternatives we have right now as a fumigant, and it's labeled for use, is Profume. This is the sulfurofluoride molecule. Totally different chemical, totally different mode of action, so we assume. We just don't know enough about mortality under different gases. We also have grain protectants, okay? So, you know, Frank talked about using a grain protectant to protect your grain as a preventive thing. Well, I have heard stories of people finding strong resistance, and they're using these grain protectants after they find infestations, but they know they can't get control with phosphine. So they're turning the bins, moving it from one bin to another, treating with one of these chemicals and putting them in another bin. And they're getting good results. I am not a commercial fumigator. I cannot say for sure this will work, but it does meet the one requirement that we've learned in school, is that, or one suggestion is, change active ingredients. So Profume is a different chemical. And all these other ones I've listed are different chemicals. I hope they're all listed as grain protectants, right, Frank? Yeah. So Sentinel and Storicide have the same active ingredient, deltametrin, as one of their killing agents. Dicon 2 doesn't kill, remember, it doesn't kill the adult insects outright, but it can have that longer-term effect of birth control, so to speak, or developmental control for the insects. Okay, we're into the summary and discussion point. And this is for the whole webinar. So we're going to be open up to all three of us. Grain insects can damage directly through the internal feeders, and then they can add to contamination, cause lots of other problems with external feeders. The main thing is, if you have live insects at the time of sale, that's going to be something that's going to affect you. IPM then, as we've talked about, should involve sanitation, and then other forms of prevention along with the sanitation, so grain cooling, use of chemical protectants, and then sampling and decision making as you go forward, and using fumigation only as needed. A lot of those preventive measures can be bin sprays, grain protectants, which are available and legal. Grain cooling, certainly, we promote this a lot, but again, a lot of the bins, particularly the concrete silos, are not going to have grain cooling, and so that needs to be addressed. Corn certainly has special concerns regarding moisture, and as Linda talked a lot about the molds, the fungi, and the mycotoxins, those are the triggers that we'll worry about with regard to safety and marketing the grain. Is you got to have, you don't want mycotoxins. And of course, a lot of the elevators buying corn will do a mycotoxin test, whether it be a crude one or an advanced one. If they flag it for mycotoxins, you've got problems. And now, most lately, if we didn't have enough problems, phosphine resistance is happening in some places. I should repeat, not to get people scared, it's not everywhere. Okay, so we are doing a geographic study across the United States, and even in many places in the Midwest, we have found zero, but we can go down the road a few miles and we can find some resistance. So the management of this is still being figured out, but we know some of the common sense ways to deal with phosphine resistance. And with that, it might be the end of this talk. So Sarah's going to moderate, okay, and we'll repeat again, maybe we'll leave it here. These are the contact informations, emails. Unfortunately, it's in a light blue for us, but you can go back to the online version and we'll send that out, and our phone numbers. And then we've listed some websites that have additional reading. Okay, the Purdue website has lots of stuff on it. That's the first one. The next one is a book that we put out here at K-State that is called Stored Product Protection, the S156. Totally free to download online, or a very low $35 if you order a hard copy. And then we've got some other stuff from entomology and that are in general about stored product insects. So I think I'll end my talk there, and we'll see where we're going with questions.
Okay, so we have one comment that came in, or a question. Would any of you comment on the usefulness of solid fumigants during bin loading?
Solid? Oh, I'm sorry.
Solid fumigants.
Yeah, sorry. That is Tom again. Tom Phillip. So the solid fumigants being the pills and the tablets of aluminum phosphide, that's pretty much how people add it to grain, is at the time that well, okay, maybe back up a little bit. We don't promote it. And the reason is this, it's a little bit of common sense, unless it's a really dirty bin. So if you do everything like we said up to that point, you've cleaned the bin, you removed all the insects from the bin, you are adding grain that doesn't have stored product insects. Now some people say, oh yeah, this will come in from the field. And there's a few cases where it's really going to be true, like Linda mentioned the Anglemoy grain moth, the AGM. That will come into the field in some cases and will continue the infestation. But most of the really common grain-destroying insects are not in the field with the corn, with the wheat. Okay, there's other field pests, and there are crickets, and there's aphids and other things. Those aren't the targets for fumigation. So I guess I'll say, and you can come back with some more questions or comments, we don't want to do it at bin loading. Okay, if you need to fumigate at the beginning, it should be an empty bin that's well sealed to fumigate that bin before you load the clean grain. The idea of turning, though, is what people do in concrete elevators. And again, we don't promote adding the fumigant at the beginning, okay, for lots of reasons. It could contribute to resistance if there are insects down in the bottom of that bin. But if it's into the season, and this is how you fumigate a concrete silo later in the season, is you turn the silo from one to another and you put in the pellets, tablets, when you're turning, and it goes into the clean bin. Now, the questioner did ask about solid fumigants, and that's a good distinction between the I can't read it on the screen here, but between that and the cylinder-based fumigants. And same thing. I mean, you don't want to use the cylinder-based fumigants until you know you need to use the cylinder-based fumigants. Especially with resistance coming, we don't want overuse of a chemical. But I will say, if I had my druthers and I had plenty of money, I would use cylinder-based fumigants for all this stuff. People might remember, the fumigators certainly will, methyl bromide has always been in a cylinder, okay? So again, if you're set up for cylinder-based fumigants and you have proper gas monitoring equipment, you can measure what the level of concentration is as you add gas from the cylinder. And the label's been changing a little bit on the cylinder-based fumigants, and you need to pay attention to that. Next question.
Okay. So our next question is, how would people know whether they have a strong or weak resistance in their area?
Yeah, again, what I talked about with strong and weak was research we're doing. There really isn't, I should say, there's maybe one or two companies I've heard about that may do a resistance detection test. The strong or weak is something we've talked about in research, but basically the weak resistance is just resistance. It's what we would call everyday resistance, and that can be tested by using one of these experiments like we use, where you treat some living adult beetles, let's just say beetles, with a very low dose of phosphine, and you determine if they survive afterwards. It's really pretty technical, though, the way we're doing it. We are not, unfortunately, we're doing research, so I'd love to hear back from you if you have insects you'd like to have tested, because at this point, I'll say, yeah, send them to me. And if I don't do it, I'll see that somebody else does it. I've got some students who need to do this stuff. We are working on the lesser grain borer, the rice weevil, the rusty grain beetle, and the red flower beetle. So we're looking at those four that are pretty common. Strong resistance, we're doing that test. When we find a high level of weak resistance, like you saw in that one MIN population, we had about 98% weak resistance. That means almost every insect in our sample just walked away, okay, to live another day and reproduce. We then tested it for strong resistance, and we found that. We're not at the point yet in this work where anybody is offering, you know, a lot of services out there in the private sector, but there are a few companies who are looking at it.
Just be aware that if you do a fumigation and you find live insects, that's a good reason why you should monitor after a fumigation. Put in probe traps to see if you have insects surviving. That'll give you an indication if you might have resistant insects in your population.
Yeah, good point. Just after a treatment, if there's insects that are alive, then somehow and it was done within a week or so. You took this sample after fumigation. They didn't reproduce immediately, or if they did, they came from pupae or larvae that didn't die from phosphine. So, yeah, common sense. I mean, whether it's weak or strong, we don't know, but it's not good.
Okay, another question. Can we utilize biological control agents as part of stored products IPM?
Linda, you want to take that one?
Yes, you can. They're just not probably as effective as you would want. But yes, there are. You are allowed to use parasites in there. You're just going to have to remember, you're adding insects to kill insects. Now, there's other biologicals that we would consider, such as BT, that you can use which is an insecticide, essentially, that you can use for the moth. So you can treat the top of a grain bin with a BT product, and then get control of your caterpillars that are crawling around to control the moths. So that would be considered a biological control agent. So there are there, but they're rarely used.
Okay, we'll wait just a minute in case anybody has last minute questions, and then we'll wrap it up. Okay. Well, I don't see any more questions, so I think we're going to wrap it up. I just wanted to say that the North Central Integrated Pest Management Center sponsored this with funds that have come from the USDA National Institute of Food and Agriculture. So we want to thank them. Also, our webinar today was recorded, and it will be stored on the North Central Integrated Pest Management Center website. And I will be sending that link out to everybody that registered. So you'll be able to view it later on or share it, and it'll be online for everybody else to see. So I thank you for connecting with us, and have a wonderful day.